Alrighty, I'm back. All right, so we're going to work on the limit comparison test. And so we'll get that started again. I know I defined it last time, but I thought, what the heck? It doesn't hurt to do it twice, especially because this one's not super easy. So here we go. Let's suppose that summation A sub n, so summation A sub n, summation B sub n. So I have two series. And they both have positive terms. So these test only works if my series have positive terms. And let's suppose that when I take the limit as n goes to infinity of a sub n over b sub n, I get something that I'll call L. So if that L is positive and finite, then the series over a sub n and b sub n either both converge or both diverge. So they both have the same behavior if the limit is positive and finite. If the limit is equal to 0 and we know that b sub n converges, then the series in a sub n converges. And if the limit is infinite and we know that b sub n diverges, then a sub n diverges. Okay, so let's look at some examples. Now, this method will usually work when the comparison test will work, but as you saw, hopefully from the previous video on the previous examples, the comparison test is a bit easier to apply. We don't have to evaluate limits. So, hey, win-win, bonus, bonus. All right, so we're going to determine whether the following series converge or diverge using the limit comparison test. So here's our lovely series, 3k squared plus k over k to the fourth plus square root of k. It's like, what? Okay, so here our a sub k's are defined by 3k squared plus k all over k to the fourth plus square root of k. So we have to figure out what's a good b sub k. So if I'm looking at my leading terms, in the numerator, I have a k squared. And in the denominator, the winner is k to the fourth, which is 1 over k squared. So I'm going to let b sub k be 1 over k squared. Does that make sense? So the squiggly line means, for our purposes, it kind of behaves like, and the winner is. Okay, so now we'll take the limit as k goes to infinity of a sub k over b sub k. So I'm looking at the limit as k goes to infinity of 3k squared plus k over k to the fourth plus square root of k divided by k squared, which hopefully you remember means that we're multiplying by 1 over k squared. Okay, so if I do that, what am I going to get? Well, let's shoot it into the numerator. So I can write this as 3 plus 1 over k to the fourth plus square root of k. And what happens is when we take the limit as k goes to infinity? Well, first of all, the numerator goes to 3, but the denominator gets larger and larger, so this limit is 0. Okay, so since the limit as k goes to infinity of a sub k over b sub k is 0, And we know that the summation k going from 1 to infinity of 1 over k squared converges, again, because it's a p series with p equaling 2, which is still bigger than 1. That tells us that, and I'm not going to rewrite k, a sub k, but that series also converges. So we know that our series converges. Yay. Awesome. So you might want to pause the video at this point, take a moment, look at this example and see if it makes sense. If not, write down some questions for office hours or next week. Okay, let's look at a second example. 1 over 2m plus natural log of m. What should we do with this one? Okay, so first of all, a sub m is 1 over 2m plus ln of m. Remember, this is a function, ln of m. All right, so let's just pick a b sub m that looks sort of useful. I'm going to go with 1 over m. We'll see if that works, right? And keep in mind that your first guess or instinct might not be the right one, but I see an m in the denominator, so I figure, what the heck, let's give it the old college try. So let's look at the limit as m goes to infinity of a sub m over b sub m. So I have the limit of m goes to infinity of 1 over 2m plus log of m divided by 1 over m. Kind of screwed up that last example, didn't I? I'll go back and fix that in a minute. Okay, so this is the limit as m goes to infinity of k of 1 over 2m plus log of m times m. So I'm looking at the limit as m goes to infinity of m over 2m plus natural log of m. All right, so if I divide the numerator and denominator by m, which is mostly what I was thinking in the earlier one, I get the limit as n goes to infinity of 1 over 2 plus ln of m over m. And we know, well, what do we know? We know the limit of log of m over m is 0. What? We did this one before. So this is going to equal 1/2, and that's since the limit as m goes to infinity of natural log of m over m is 0. If you don't see that, think of f of x being log of x over x. Apply L'Hopital's rule. Where you take the limit, you get 0. Okay, so since the limit as m goes to infinity of a sub m over b sub m is 1/2, which is greater than 0 and not finite. And we know that the summation m going from 1 to infinity of 1 over m diverges because it's the harmonic series. That tells us that the summation m goes from 1 to infinity of 1 over 2m plus natural log of m diverges. And now I'll go. So now you should pause, see if you have any questions, think about it, and I'll go back and clean up that example that I screwed up. Now you actually have all of the comforts of being in class. Take 2 divided by 1 over k squared, which means I'm multiplying by k squared, which means I'm looking at the limit as k goes to infinity of 3k to the fourth plus k cubed over k to the fourth plus square root of k. And I'm going to divide the numerator and denominator by k to the fourth this time. And when I do that, I get 3 plus 1 over k, except that this becomes, the denominator changes here. And the tablet freezes. This becomes a 1, and this becomes a k to the minus, I don't know what. 1/2 minus 1/4, 1/2 minus 1/4, 1/2 minus 4, 1/2 minus 8, negative 7 halves. So I guess 0 is probably out. Would you go for 3? Which is finite, and since the first series converges, the second one does as well. Okay, so now you should shut off the video and try to work on this one on your own. And I'm actually going to pause my recording, I think, for a moment so that is not what I wanted. Alrighty, so where were we? We were here. I'd like to determine whether or not this series converges. Okay, so let's do this. A sub n is cosine squared n over 3 to the n. We know that cosine is bounded by, cosine squared is bounded by 1, right? It's between 0 and 1. So let's let b sub n be 1 over 3 to the n. All right then. What's the limit as n goes to infinity of a sub n over b sub n? That is going to be cosine squared n over 3 to the n divided by 1 over 3 to the n. So I'm looking at the limit as n goes to infinity of cosine squared n over 3 to the n times 3 to the n, which is the limit as n goes to infinity of cosine squared n, which technically speaking does not exist, of course. But that, and what does that tell us? That tells us that the limit comparison test was a bad idea. All right, so we would be like, oops, my bad. So one thing you want to keep in mind is don't go straight for the limit comparison test. Instead, try the comparison test first. And if the comparison test fails, then go to the limit comparison test. So let me take a moment. And since I've demonstrated what not to do, I figure it'd be nice if I demonstrate what to do. So let's start this problem again. At least I'm going to start this problem again. Nice thing about this is that you have the video, so you could see where I went wrong, and you could see where you might go wrong. All right, so, well, a sub n is still cosine squared n over 3 to the n. And since 0 is less than or equal to cosine squared n less than or equal to 1, we could say that a sub n is cosine squared n over 3 to the n is less than or equal to 1 over 3 to the n, and that's going to be our b sub n. And we know that summation n going from 1 to infinity of 1 over 3 to the n converges, right? Because you can write this as 1 over 3 to the n converges, right? Because it's a geometric series where r is 1/3, which is less than 1. Awesome. So since cosine squared n over 3 to the n is less than or equal to 1 over 3 to the n, and this series converges, what does that tell us? By the comparison test, our original series converges. And in fact, I will write by the comparison test. It's always good to know what test we've been applying. And so that's the idea. I hope that this makes sense. There are some exercises for you, and of course the homework on Newton will be there for you at the appropriate time. Again, stay safe. Let me write converges a little bit better, but stay safe, and hopefully I'll see you next week, at least video see you. All right, everybody, take care, stay well, and I'm out.